Now we're going to talk about what we call the ambiguous case, side-side angle. This is really complex, so stick with me, practice the problems, and it'll all start to make sense. But I'm going to tell you right now, it's a little confusing. You're going to get frustrated because there's so many parts to it, but it's really, really important. So try to take good notes, maybe stop and rewind if you need to and listen to the explanation again. I think it'll be really helpful. Okay, I'm just telling you right now, it's going to be complex. Now the ambiguous case, or when we know two sides at an angle, it's called the ambiguous case because ambiguous means you don't really necessarily know the answer to something. It could be one way or it could be another. So the ambiguous case is when you know two sides and a non-included angle. So in this particular case, we might be looking at maybe side B, side A, and we know angle A. So that angle that we've been given, we call that non-included because it's not the angle that the two sides we have values for. It's not the angle that those two sides make. Okay? So this is in the relationship of side-side angle. Now, when you have information like that, in other words, when I give you the lengths of sides, two sides, and an angle that's not in between those two sides, there's actually some funny stuff that can happen. Sometimes there's more than one triangle that could be created with those sides and that angle measure. And I'm going to show you what that looks like now. And you definitely want to draw these diagrams as well as you can and neatly in your notes. So what I want you to do is consider a triangle where you've been given those values. You've been given side A, side B, and angle A. Here are the different things that could possibly happen with those given measurements. Okay? Now there's two initial things that could happen. Either the angle that you've been given is going to be acute or it's not. It's going to be obtuse. It's not going to be a 90-degree angle. We're only talking about acute or obtuse angles. So all of these examples up here reference what happens when A is acute. And then down here, we're going to look at what happens when A is obtuse. Now, if A is in fact acute, then there's 4 different possible triangles that could be created. Okay? Now, the thing that's important is comparing the length of A to either the length of side B here or to the height of the triangle. So I want you to keep those two things in mind. Now in the first example, let's say that A was less than the height. Remember, we can find that height. That height is found just like we did in the area of a triangle. That height is found by taking the length of side B and multiplying it by the sine of A. That's basically setting up your trigonometric ratios and solving for a side. So if we know B and we know A, we can actually find the height. Now if A is smaller than what that height would be, this triangle actually doesn't exist. It's almost as if this side was too short. B here is pretty long. H is not quite as long as B. And then A is even shorter than both of those. And if it's too short, there's no way it's going to reach that third side. So if A is acute, angle A is acute, and side A is less than the height, then there are no triangles that can be created. All right, let's go to the next example, the next possibility. Well, what if you figure out the height, you go B side A and you get the height, and it's exactly equal to side A? Well, in that case, there's only one triangle that's possible, and it would be a right triangle. Now, the third possibility, and I have this actually written incorrectly in the notes here, so let me change it real quick so that you make sure you write it correctly. This should actually read is greater than. If A is greater than side B, and angle A is acute, no problems. There's only one triangle that can be made. Sorry about that. I meant to just underline it. One triangle that can be made, and you're just going to use the law of sines to solve that triangle. That's going to be the first example that we do. Now here's the one that's very, very tricky. Once you find that height, if it turns out that side A is bigger than the height, but it's less than side B, there's actually 2 different triangles that could be created using those side lengths. And so let me highlight those 2 triangles here. So remember, we know angle A, we know side B, and we know side A. And I know this is kind of, my lines aren't very straight here, but it's hard to do it with a mouse. So see this triangle right here? That's one of the triangles that could be created. The other triangle that could be created is, I don't know, this kind of normal looking triangle that you see. Let me see if I can draw it a little bit better. This normal looking triangle that you see here. Okay, so we have side A, angle A, side B. I hope you guys can all visualize it because this is kind of the hard part of solving this side-side angle case. Now you can see it even looks like it. Those two lengths are exactly the same. So there's two different triangles that could be created when you've been given side A, side B, and angle A. Now I want you to consider if angle A is obtuse. If angle A is obtuse, there's two possibilities. Now since this is the obtuse angle, in theory, side A would have to be the longest side. If it's not the longest side, in other words, if A is less than B, there's no way that this triangle could even exist. In other words, this side would be too short, it would never reach the third side. The other possibility is if A is greater than B, and that's what we're looking for. If A is greater than B and angle A is obtuse, wonderful. There's only one solution possible. We're going to use the law of sines to proceed and solve the triangle. Okay, so the first example that we're going to do, or example 2, after the area problem, is we're going to inspect what happens when there's only one solution possible. This is the easy case. After that, we'll look at what happens when we have some more difficult or complex cases. But let's start with the simplest case first, okay? So here we go. Example 2, the single solution case for side-side angle. I'm going to try to move this back over here. All right. Now, again, I want you to put the problem over here on the left-hand column. But let's solve the triangle. If we know that angle A is equal to 38 degrees, we know side A is equal to 6, and side B is equal to 5, let's solve the triangle. Of course, the first step is to draw a diagram, right? So I'm trying to draw an angle that I think looks like 38 degrees. I label my triangle ABC. Here's side A over here, it's 6. Here's side B over here, it's 5. Wonderful. So we drew our diagram. Now we want to make that comparison of A to B. And in this case, since side A is longer than side B, there's only one solution possible. Remember, I had to fix that in the notes down here. Sorry, I went back a page. This right here. As long as that angle is acute and side A is longer than side B, there's only one solution possible. All right, well, that's wonderful. There's one solution possible. Let's find it. So what we're going to do is use the law of sines to solve for one of the missing angles. Since I know this side and this angle, I can say 6 over the sine of 38 is equal to this side divided by this angle, or 5 over the sine of B. So we're going to use this to help me find angle B. But wait a minute. Remember there was that alternate version of the law of sines that we could use? So what we're going to do is flip those fractions. And I'm doing that just to keep my variable on top. It keeps things a little bit nicer for me. No big deal. So we say the sine of 38 over 6 is equal to the sine of B over 5. Okay, so if I want to solve for B, I'm going to multiply both sides by 5. And when I do that, over here, these are going to cancel, or they're going to divide out to equal 1. And on the other side, we're going to have 5 times the sine of 38 divided by 6. But remember, that's actually equal to the sine of B. So if I do the division here, if I multiply 5 times the sine of 38 and divide by 6, I get this decimal value, about 0.513. Okay, now remember that's equal to the sine of B. So if we want to find angle B, we have to take the inverse sine. And you might actually even want to write that over here on the right if you're writing down your steps. And I know it's really hard for me to write with a mouse, so I'm sorry. You can write neater. Take the inverse, and then we'll say the inverse sine. Wonderful. Take the inverse sine. So B is equal to the inverse sine of 0.0513, or excuse me, 0.513. And if I do that inverse, I get that angle B is about 30.8 degrees. So if I go back to my picture, and I'm going to scroll up here, I would fill in this angle is 30.8 degrees. Now we're not finished because we have to solve that whole triangle. That means we have to find angle C and we have to find side C. Okay, well I know two angles of the triangle, so I can find angle C by adding them together and subtracting from 180. So I'm going to do that next. So we find the third angle by subtracting from 180. So 38 plus 30.8 is 68.8. I subtract that from 180 and I get angle C is 111.2. So again, I might fill that in my picture to keep track of everything that I found. 111.2. Okay, so now all we have to do is find that third side. Of course, we can't use Pythagorean theorem because this is not a right triangle, but we can use the law of sines. So we'll start with those knowns that we were given at the beginning of the problem, side A and angle A. So 6 over the sine of 38 is equal to C over the sine of 111.2. So we multiply both sides by the sine of 111.2, and I think the sine fell off here when I wrote that, but we'll multiply both sides by the sine of 111.2. So that's going to divide out over here. So C is going to be equal to 6 times the sine of 111.2 divided by the sine of 38. And then when we do that math on the calculator, we multiply it 6 times sine 111.2 divided by the sine of 38. We get C is equal to 9.08. Now I just want to go back to my diagram here for a second and think about that value. Always check your answer for reasonability. Does it make sense that this side would be 9.08 if my other sides were 5 and 6? Absolutely. It's clearly the longest side in the triangle. C is the biggest angle, so that fits really, really nicely. Okay, so what I want you to do right now is try problem number 2 on the handouts. Okay, and again, I'm going to stop the recording here just so I make sure that I don't go over my time limit for YouTube. Okay, and then we'll pick up examples 3 and 4 in the last recording.